Have you ever imagined sipping your morning coffee while floating through your kitchen, or waking up to witness our beautiful blue planet right outside your window? Today, we're going to explore one of humanity's greatest achievements, our home in space, the International Space Station. This remarkable orbital outpost represents far more than just a technological marvel. It stands as a testament to human ingenuity and international cooperation. Soaring 400 kilometers above Earth's surface, the ISS races through space at an astounding speed of 27,600 kilometers per hour. At this velocity and altitude, the station's inhabitants experience something truly extraordinary: 16 sunrises and sunsets every single day. A reminder of how different life becomes when you're living among the stars. This incredible vantage point offers astronauts a perspective that few humans have ever experienced, making them witnesses to the breathtaking beauty of our planet from a truly unique perspective. The International Space Station serves as humanity's embassy in Earth's orbit, a place where the boundaries of nations dissolve into the vast expanse of space. This remarkable achievement is the product of unprecedented collaboration between 15 different countries, showcasing what we can accomplish when we work together across borders and cultures. The station stands as a shining example of how international cooperation can overcome tremendous technical, political, and logistical challenges to achieve something greater than any single nation could accomplish alone. For those who have ever dreamed of becoming an astronaut or find themselves captivated by the mysteries of space, the ISS represents more than just a scientific laboratory or technological achievement. It represents humanity's first permanent outpost beyond Earth, a stepping stone to future exploration, and a symbol of our species' unquenchable desire to push beyond our known boundaries. Every experiment conducted, every discovery made, and every lesson learned aboard the station brings us one step closer to understanding our place in the cosmos and realizing our potential as a spacefaring civilization. For anyone who shares this passion for space exploration and dreams of reaching for the stars, I invite you to join us on this cosmic journey. Together, we'll explore the universe, uncover its mysteries, and witness the incredible achievements that make space exploration one of humanity's most inspiring endeavors. This is just the beginning of our adventure into understanding life aboard the International Space Station, where every day brings new challenges, discoveries, and opportunities to push the boundaries of human knowledge. Whether you're a long-time space enthusiast or just beginning to discover the wonders of cosmic exploration, there's never been a more exciting time to be part of this journey. The story of the ISS is the story of human perseverance, international unity, and our endless quest to understand our place in the vast cosmic ocean that surrounds us. Life in microgravity presents one of the most fascinating and challenging aspects of space exploration, fundamentally changing how the human body functions and adapts. When astronauts first arrive at the International Space Station, their bodies immediately begin a remarkable transformation process that scientists are still working to fully understand. One of the most dramatic changes occurs in the musculoskeletal system. Without Earth's gravity constantly pulling on their bodies, astronauts' muscles begin to atrophy, and their bones start losing density at an alarming rate, up to 1.5% per month in some cases. This process occurs because the body, no longer needing to fight against gravity, begins to shed what it perceives as unnecessary muscle mass and bone density. The changes are particularly noticeable in the legs and lower back, areas that typically work hard against gravity on Earth. The phenomenon known as space face is another intriguing adaptation to microgravity. On Earth, gravity pulls bodily fluids downward, but in space, these fluids redistribute more evenly throughout the body. This causes astronauts' faces to appear puffy and congested while their legs become thinner. a condition astronauts often describe as feeling like they're hanging upside down. This fluid shift can also cause headaches and congestion during the first few days in space, a condition informally known as space head. Sleep presents its own unique challenges in the microgravity environment. Without a clear sense of up or down, astronauts must completely relearn how to rest. They sleep in small crew quarters, secured in sleeping bags that are tethered to the wall. Without this anchoring, they would float around their cabins while sleeping, potentially bumping into equipment or other crew members. Many astronauts report that the sensation of floating while sleeping is actually quite peaceful once they get used to it, though it can take several days to adjust to this new normal. To combat the physical effects of microgravity, particularly muscle atrophy and bone loss, astronauts must maintain a strict exercise regimen. Each crew member spends approximately 2 hours every day exercising, a requirement that's as crucial to their health as eating or sleeping. This isn't just about maintaining fitness, it's about ensuring they'll be strong enough to function when they return to Earth's gravity. The exercise equipment aboard the ISS is specially engineered to function in microgravity and requires innovative solutions to replicate Earth-based workouts. The Advanced Resistive Exercise device uses vacuum cylinders to simulate the weightlifting experience in space. Astronauts also use a specially designed treadmill that keeps them in place with a harness system and bungee cords. This treadmill, named after comedian Stephen Colbert, allows them to run in space, maintaining their leg muscles and cardiovascular health. A specialized bicycle ergometer rounds out the exercise equipment, allowing astronauts to perform cardiovascular workouts while strapped to the device to prevent floating away. These exercises are carefully monitored and adjusted based on each astronaut's needs in response to the space environment. Data collected during these exercise sessions also provides valuable information about how the human body adapts to long-duration spaceflight, crucial knowledge for planning future missions to Mars and beyond. The impacts of microgravity on the human body remain one of the most significant challenges in space exploration, and the ISS serves as an invaluable laboratory for understanding these effects. Through careful study of these adaptations and the development of countermeasures, we're not just learning how to keep astronauts healthy in space, we're gaining insights that could benefit medical treatment on Earth, particularly in areas such as osteoporosis prevention and muscle atrophy treatment. Life aboard the International Space Station follows a meticulously planned daily routine, beginning each morning at 6 hours GMT. This synchronized schedule is crucial for coordinating activities with mission control centers around the globe and ensuring the smooth operation of this orbiting laboratory. While the clock may say it's morning, the concept of day and night becomes rather abstract when you're witnessing 16 sunrises every 24 hours. Starting the day in space presents unique challenges that most of us never consider on Earth. Upon waking, astronauts must deal with personal hygiene in an environment where water doesn't flow downward and toothpaste doesn't stay on the toothbrush without careful handling. They use special no-rinse shampoo and moistened towelettes for cleaning, as traditional showers are impossible in microgravity. Even brushing teeth requires a unique approach. Astronauts use a small amount of water from a pouch and must carefully capture any stray droplets that float away. Maintaining personal hygiene in space requires specially designed tools and techniques. For instance, astronauts use a special vacuum-like hose while cutting their hair to prevent loose strands from floating around the station. Even washing their faces requires careful consideration. Water must be squeezed from sealed pouches and carefully applied to prevent droplets from escaping into the station's atmosphere. Mealtimes in space are particularly fascinating. Space food has come a long way from the squeeze tubes of the early space program, but it still requires special preparation and careful handling. Most foods are dehydrated or thermostabilized and come in sealed packages that must be carefully opened to prevent food particles from escaping. Water is added to dehydrated foods through a special needle-like system, and astronauts use special utensils designed to prevent food from floating away. Condiments like salt and pepper come in liquid form, as loose granules would float away and could damage equipment or irritate eyes. One of the most captivating aspects of daily life in space is drinking water. Without gravity, water forms perfect floating spheres that astronauts can capture with their mouths or special drinking straws. While this might seem fun, it requires careful attention. A mishandled water bubble could float into sensitive equipment. The same physics that makes water form these fascinating spheres also affects everything from coffee to juice, requiring specially designed containers for all beverages. Taking a shower in space is perhaps one of the most significant adjustments astronauts must make. Instead of traditional showers, they use a combination of no-rinse shampoo, rinseless soap, and moistened towelettes. For more thorough cleaning, they can use a special enclosed chamber with airflow that helps keep water droplets contained. The water forms a film around their bodies instead of falling downward, creating an experience entirely different from Earth-based bathing. Sleep presents another unique challenge. Astronauts must secure themselves in sleeping bags that are attached to the wall of their small private crew quarters. Without these restraints, they would float around while sleeping, potentially bumping into equipment or other crew members. The sleeping bags are designed to be well ventilated, as warm air doesn't rise in microgravity and could create uncomfortable pockets of heat around the astronaut's body. This remarkable daily routine in space, with all its challenges and innovations, represents humanity's ongoing adaptation to living in an environment for which our bodies were not designed. Each solution to these daily challenges not only makes life in space possible, but also contributes to our understanding of physics, biology, and human adaptation. What fascinates you most about life in space? Is it the floating water bubbles, the unique sleeping arrangements, or perhaps the creative solutions for everyday tasks we take for granted on Earth? Share your thoughts in the comments below. And don't forget to like this video to help others discover these fascinating insights into life aboard the International Space Station. Your engagement helps us continue sharing these incredible stories of human achievement in space exploration. The International Space Station serves as humanity's premier orbital laboratory, where the unique environment of microgravity enables groundbreaking research that's impossible to conduct on Earth. This floating scientific haven has become the birthplace of discoveries that are revolutionizing our understanding of physics, biology, and materials science. In the realm of crystal growth, microgravity provides an unparalleled advantage. On Earth, gravity-induced convection and sedimentation often create imperfections in crystal structures. However, in the space station's weightless environment, crystals can grow in nearly perfect three-dimensional shapes. This has profound implications for pharmaceutical research, as protein crystals grown in space are often larger and more pure than their earthbound counterparts. These superior crystals help scientists better understand protein structures, leading to more effective drug designs for treating diseases like cancer, Alzheimer's, and various genetic disorders. The behavior of fire in space has revealed fascinating insights about combustion. Without gravity-driven convection, flames in microgravity form perfect spheres instead of the typical teardrop shape we see on Earth. These space-based fire experiments have led to improved understanding of combustion efficiency, helping engineers design better engines and develop more effective fire safety systems both in space and on Earth. The research has also revealed that fire can burn at lower temperatures and with less oxygen in microgravity, findings that have important implications for fire safety in space and improved fuel efficiency on Earth. Human physiology studies in space have provided unprecedented insights into how our bodies adapt to extreme conditions. The absence of gravity affects everything from bone density to heart function, making the ISS an ideal platform for studying aging, muscle atrophy, and cardiovascular health. These studies have led to breakthroughs in understanding osteoporosis, balance disorders, and immune system function. The research has also helped develop treatments for muscle-wasting diseases and improved our understanding of how the human body might adapt to future long-duration space missions to Mars and beyond. Medical advances from space research have been particularly significant. Studies of astronauts' cardiovascular systems have led to improved cardiac monitoring devices now used in hospitals worldwide. Research into bone loss in space has contributed to better treatments for osteoporosis on Earth. The development of artificial blood vessels, grown in microgravity conditions, has shown promise for cardiovascular surgery applications. Additionally, research into the effects of isolation and confinement on astronauts' mental health has provided valuable insights for treating depression and anxiety. The development of new materials in space has yielded remarkable results. Without gravity-induced segregation, scientists can create metal alloys that are impossible to produce on Earth, resulting in stronger, lighter materials for use in everything from aircraft engines to medical implants. Experiments with colloids, mixtures of microscopic particles suspended in fluids, have led to improvements in products ranging from cosmetics to food preservation systems. Perhaps most surprisingly, many technologies we use daily have roots in space station research. Advanced water purification systems developed for the ISS are now used in remote areas on Earth to provide clean drinking water. Improved air filtration systems designed for the station have found applications in hospitals and clean rooms. LED technology, refined through space-based plant growth experiments, has revolutionized indoor farming and lighting efficiency on Earth. The ISS has also become a platform for testing new technologies that could revolutionize space exploration itself. Experiments with 3D printing in space have demonstrated the potential for manufacturing replacement parts and tools on demand during long-duration missions. Research into closed-loop life support systems is helping develop technologies that could sustain human life on Mars and other distant destinations. These scientific achievements represent just a fraction of the groundbreaking research conducted aboard the ISS. Each experiment adds to our understanding of life, matter, and the universe itself, while simultaneously improving life on Earth through practical applications of space-based research. The station continues to serve as a testament to human ingenuity and our capacity to transform seemingly impossible challenges into opportunities for advancement and discovery. Life aboard the International Space Station presents a unique set of challenges that test both the technical expertise and psychological resilience of its crew. Operating in the harsh environment of space requires constant vigilance and innovative problem-solving skills to ensure the safety and success of the mission. The technical challenges of maintaining the ISS are formidable. The station operates in an extremely hostile environment where temperatures can fluctuate between +120 in direct sunlight to 150-70 in shadow. This extreme thermal cycling puts tremendous stress on the station's materials and systems. Astronauts must regularly perform maintenance tasks while wearing bulky spacesuits that significantly limit their dexterity and movement. Even simple repairs become complex procedures in space, where tools can float away, and the absence of gravity makes conventional repair techniques ineffective. Dealing with leaks and repairs presents particularly critical challenges. The station must maintain precise atmospheric pressure and composition, making any potential leak a serious concern. When leaks are detected, crews must work methodically to locate and repair them, often using specialized equipment to detect the precise location of air loss. In 2020, for example, crews spent months tracking down a small but persistent air leak, eventually using floating tea leaves to help visualize air movement and locate the source. Communication with Earth, while highly advanced, presents its own set of challenges. Despite sophisticated systems, signal delays and interruptions can occur as the station orbits the Earth every 90 minutes. The crew must maintain constant contact with multiple control centers around the globe, coordinating activities across different time zones and languages. This requires precise scheduling and careful attention to communication protocols to ensure critical information is accurately conveyed. The psychological aspects of space station life present equally significant challenges. Living in confined spaces for months at a time, far from family and friends, tests the mental resilience of even the most well-trained astronauts. The isolation is profound. While crews can communicate with Earth, the physical separation from loved ones and the inability to experience simple pleasures like feeling rain or breathing fresh air can take an emotional toll. Living in close quarters with a small group of people for extended periods requires exceptional interpersonal skills. The international nature of the crew adds another layer of complexity, as astronauts must navigate cultural differences and language barriers while working together in high-stress situations. The success of the mission depends on their ability to form cohesive teams despite these challenges, supporting each other through difficult times and maintaining positive working relationships in an environment where there's literally no escape from one's colleagues. Homesickness affects every crew member differently, but remains a constant companion during long-duration missions. Missing important family events, children's milestones, or simply the comfort of home can be emotionally challenging. Astronauts develop various coping strategies, from scheduling regular video calls with family to bringing personal mementos aboard. The psychological support team on Earth plays a crucial role in helping crew members maintain their mental well-being, providing regular counseling sessions and facilitating family communications. The ISS also experiences a unique phenomenon known as the overview effect, a cognitive shift reported by astronauts when viewing Earth from space. While this can be profoundly positive, helping crew members gain a new perspective on humanity and our planet, it can also intensify feelings of isolation and separation from the world they know. Despite these challenges, the human spirit of exploration and discovery prevails. Crews develop strong bonds through shared experiences, often describing their time on the station as life-changing. The international cooperation required to maintain and operate the ISS demonstrates humanity's ability to overcome national boundaries and cultural differences in pursuit of common goals. The success of the International Space Station program shows that with proper training, support systems, and human ingenuity, we can overcome even the most daunting technical and psychological challenges. Each problem solved and obstacle overcome not only ensures the continued operation of this remarkable orbital outpost, but also paves the way for future long-duration space missions to more distant destinations. The International Space Station stands as a shining testament to what humanity can achieve when we work together across borders and cultures. For over 2 decades, this remarkable orbital laboratory has demonstrated that international cooperation isn't just possible. It's essential for advancing our species' greatest endeavors. Through political tensions, global challenges, and technical obstacles, the ISS has remained a beacon of collaborative achievement, where astronauts from different nations work side by side in the pursuit of scientific knowledge and human advancement. As we look toward the future of space exploration, the lessons learned from the ISS program prove invaluable. The station has served as an unprecedented testing ground for technologies and human adaptation to space, providing crucial insights that will guide our next giant leaps into the cosmos. From advances in life support systems to breakthroughs in materials science, every discovery made aboard the ISS brings us closer to achieving our dreams of establishing a permanent human presence beyond Earth orbit. The journey to Mars represents humanity's next great space adventure, and the ISS has been instrumental in preparing us for this monumental challenge. The station has helped us understand the long-term effects of microgravity on the human body, develop reliable life support systems, and test technologies that will be crucial for deep space missions. Perhaps most importantly, it has taught us how to maintain complex spacecraft systems far from Earth and how to support crews living in isolation for extended periods, both essential capabilities for future Mars missions. The psychological insights gained from ISS missions are equally crucial for Mars exploration. We've learned how to maintain crew morale during long-duration spaceflight, manage international teams in high-stress environments, and develop effective countermeasures for the mental challenges of space isolation. These lessons will be invaluable as we prepare for missions that could last years rather than months. As we stand on the brink of a new era in space exploration, with plans for returning to the Moon and eventually reaching Mars, the International Space Station continues to serve as both a stepping stone and a symbol of what's possible. It reminds us that our greatest achievements come not through competition, but through cooperation, not through division, but through unity in pursuit of common goals. The legacy of the ISS will extend far beyond its operational lifetime. The technologies developed for the station, the scientific discoveries made aboard it, and the international partnerships forged through its operation will continue to benefit humanity for generations to come. As we look to the stars and dream of new destinations, the ISS stands as proof that with dedication, cooperation, and unwavering commitment to exploration, no challenge is too great for humanity to overcome. Want to continue exploring the universe with us? Don't forget to hit the notification bell to stay updated. Here at Exploring the Universe, every week brings a new space adventure that you won't want to miss. The International Space Station is more than just a technological marvel orbiting our planet. It's a symbol of hope, a testament to human ingenuity, and a promise of what awaits us among the stars. As we continue to push the boundaries of space exploration, the lessons learned and partnerships forged through the ISS program will light our way forward into the cosmic frontier.